This lesson is tangents. We're going to solve problems when tangents intersect a circle. So here's a theorem. If a line is tangent to a circle, and remember when a line is tangent to a circle, it touches the circle only once. The rule says that if it's tangent, then it is perpendicular to the radius drawn to the point of tangency. So if segment AC is a tangent, then radius DB is perpendicular to it. So that gives us right angles there. It might also give us, anytime we have right angles, we might want to be on the lookout for right triangles. So it's possible we would create a right triangle there and end up doing some Pythagorean theorem with the side links there. Lots of things can happen. Now also notice that tangent can be a noun, where I can say that segment AC is a tangent, where that means it touches the circle at one point. Or you could use it as an adjective, where I could say segment AC is tangent to the circle. So they both essentially mean the same thing. It is a tangent and it is tangent. In the end, though, it simply means it touches the circle once. So here's an example. If we have a tangent here, segment CB is a tangent, and it's perpendicular to the radius, as it needs to be, find the value of segment AC. Well, since it's perpendicular here, we can have it closed up, making a right triangle. And anytime you have a right triangle, you can do the Pythagorean theorem. Segment AC is the whole hypotenuse, so we can do the Pythagorean theorem where the legs are 3 and 4, and the hypotenuse is AC. That's a 9 plus 16 is 25. And then when you square root both sides, square root of 25 is 5. Square root of AC squared is AC. So the measure of segment AC is 5. A tangent is perpendicular to a radius drawn to the point of tangency. And be prepared for right triangles and using the Pythagorean theorem. Another theorem says that if two segments from the same exterior point are tangent to a circle, then they're congruent. So segment BC is tangent and segment BA is tangent. Since they're tangent to the same circle, then those segments are congruent. Imagine if you were standing at B and these two segments were your arms and you're holding a beach ball. You're holding a beach ball at the point of tangency on each side, and your arms are the same length. That's all it means. So when you have two tangents that hit the same exterior point, then they're congruent. So look at this example. Find the value of segment CE and segment AE. So I have several places here where there's two tangents that hit the same exterior point. At the top here, segment AB and segment AF do that, so they're the same, 1.8 and 1.8. You also have segment EF and segment ED. Since segment EF is 7, and segment ED is also 7. You also have segment CD and segment CB. Those are also tangents that hit the same outside point. Since CD is 2.4, then CB is also 2.4. So each of these around each corner here ends up being the same segment length. Now, let's find CE. From C to E, do segment addition. That's a 2.4 plus 7. Which is 9.4 centimeters. For segment AE, do segment addition again. That's 1.8 plus 7, which is 8.8 centimeters. So when you have two tangents that hit the same outside point, then those tangents are congruent. 1.8 and 1.8, 7 and 7, 2.4 and 2.4. And then remember that a tangent is perpendicular to the radius, which would give you a right angle and a possible right triangle to do Pythagorean theorem with.